graph is discontinuous at an asymptote. Okay, it's kind of like sympathy. Same root there, asymptote. Okay, it's discontinuous. Okay. And so what did we know about the domain of this? We said that the domain is, we had a graph.
It's X.
That was, I think it was going like this. It was approaching a -2. So your graph, something like that. And what was here? That asymptote.
Okay. The other asymptote.
Delivered.
Okay, so what would the domain be? The domain? Good. All the real numbers. Nice job, Eli. So the domain, all the real numbers except, well, no, we're going to do something else. All real numbers except at x equals,
Is it all real numbers above -2?
at, well, isn't it below -2 as well?
So except that x equals.
Except at x equals -2. Okay, so could we tell that by just looking at this? Okay, because I know that if there's a 0 there, it is going to be undefined. Okay, let's try this problem. Pardon me? Right, okay. Let's try x squared minus 1 over x squared minus x minus 2. And what do you think we're going to try to do? What do you see right here?
Difference of perfect squares.
Factors, we're going to factor. That's right. Da, 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 da.
That's a difference.
Yes, I think we need to do a song or something or a rap
I
for
heard that you had a video about why it was MX displayed. I would like to see it.
this. Well, on a
This
good
one,
day,
so
all right.
Let's have a perfect.
I did.
Yeah, is that a difference of perfect squares on top?
Yeah, no, yes, the one on top.
And then put it in the
I
graph.
can't find my markers. I need to have a retractable marker thing. Anybody see my marker? 'Cause I can't see it. How can I lose these stupid things?
That red one's still killing me.
I know. All right. So let's go. Emily, focus. We only have a few minutes. I'm going to give you a worksheet. So I'm going to factor this. X minus 1, x plus 1. Are we good with that? And Emily, and then we have x. What are the factors of the in the denominator? X minus 2, x plus 1. Okay, graph that. So you can graph it in this form if you wish. You don't have to do that.
Can't factor or.
Pardon me?
Can't you get rid of the x?
Hold on a second. I want you to look at it first.
Yeah, I said that 20 minutes ago.
Clear. Okay, so we're going to do, let me see, x squared minus 1
Will this just be x?
divided, shoot, minus 1 divided by, now putting the parentheses, parentheses helps, x squared minus x minus 2, and I'm graphing that. Okay. I'm going to do it.
Why did we have to factor?
Oh, I saw the graph all these.
Okay.
Whoa. What is that?
All right, did everybody get a graph like that?
Why is this like a
No, I
heartbeat?
messed one up.
Okay, so I went back, I put in parentheses, so I have x squared minus 1, and that's divided by parentheses x squared minus x minus 2, parentheses. You know, the calculator isn't always clear. You really need to work on using parentheses. So where does it appear it is undefined?
2.
Yeah, 2.
at negative 2.
No.
But why? Oh, I'm sorry. Okay, well, if I set this equal to 0, x minus 2 is equal to 0, x would have to be
2?
2. Okay, what about this one?
Negative.
Okay, now, your calculator doesn't show this very clearly, but there is a hole there. And this is discontinuous. So in this particular graph, there's a hole because could I cancel that out?
Yes.
Okay, so there's a hole there, and you need to know that it's discontinuous at x equals negative 1, but there's what at x is equal to 2? There's an asymptote. So the asymptote won't go away. Okay, it's there. So the only time that it has a hole is if there is stuff. Oh, don't go away. I'm giving you a worksheet to do. The only time that it will be an asymptote, a hole, is if there's a factor. Let me see. So you're doing the whole 8, 3, C. That whole side, 3, 4, 5, yes. 8, 3, C. There's 2 sides to this sheet. I'm only asking you to do the 8, 3, C side. And then on